Welcome to N is for Networking, the podcast for newcomers to the world of pushing packets. Relative newcomer, Holly Metlitsky is your co-host, and I'm Ethan Banks, a seasoned network engineer who's seen a thing or two. You can connect to us on LinkedIn, and please do. N is for Networking is part of the Packet Pushers podcast network. If you love networking, we've got several other shows you might like, including Heavy Networking, Network Automation Nerds, Total Network Operations, Packet Protector, and more. We've also got newsletters, a Slack group, a YouTube channel, IRC, and more. Find all of that at packetpushers.net. On today's episode, Holly and I will discuss one of the topics we've been asked about the most, the 7-layer OSI model. Holly, they want us to talk about the OSI model. Now, in your training, because you did a bunch of training with Juniper, you've taken a bunch of tests and got a bunch of certs. The OSI model has come up, would you say?
It was the first thing I learned about, which I'm not quite sure if that's the right order to do it, because you learn about a bunch of things in the OSI model that you haven't heard about before. But it was my foundation.
Okay, so you're familiar with this territory on some level. So, I having been in networking for a lot of years now, I have mixed feelings about the OSI model. It's useful in some ways and really not useful in a lot of other ways. But yet it's so embedded in what we learn as network engineers, in the books we read about network engineering. It just shows up everywhere. Like you said, it's the first thing. Okay, well, let's go through it because people have been asking us, right? So here's my take. Is that a model is a reference, it's a way to see the world, and the Open Systems Interconnection model, the OSI model, is a way to look at networking. And the reason I think it came up first in your training, Holly, is because it gives instructors a reference point, kind of a way to start mapping all of these protocols and concepts to something, to a model that you can begin to use to build in your mind the networking world. That's kind of how I think of it. Is that reasonable?
Yeah, I think it gave a basis almost to stack. I mean, I don't mean not, no pun intended, but like to layer topics,
Yeah.
So you can start with, this is X and Y, and this relates to this layer. And like you said, you can build on that having a model to reference it to. But obviously not everything relates to a model because it's just a reference, which I think is something we forget at times.
And the OSI model in particular falls short, or there are things that have been created in networking that don't neatly map to the OSI model, which is why I feel it's of limited use. Nonetheless, it's still got usefulness. It's still got some usefulness. And I think, I don't know, should we just start jumping through the different layers of what they are, Holly? Because there's 7 of them, and maybe we just talk through them one at a time and kind of see what's going through. Well, you've been through this. Do you want to lead us off, kick off what the first layer is?
Sure, I definitely, my favorite layer. the physical layer. So, that's where you have ones and zeros going across the physical medium in some way. It's the actual bits that are streamed across that you can measure with an oscilloscope.
Oh, sure. Exactly right. So, yeah, if you were to talk about the physical layer, we're talking about literally like getting down to the cables, getting down to like the radio signals, what's actually being transmitted through the air. Because at the end of the day, a network, as we've talked about in previous episodes, is carrying data packets from one place to another. And at some point, it gets real. It gets right down to the physical layer. And that's what the OSI model, that would be, I guess that'd be our bottom layer, what everything is built on, would be that physical layer. And you mentioned an oscilloscope. So, right, you could actually look with an oscilloscope at electrical signals going across a copper medium, let's say, and see a waveform and see how the waveform changes as ones and zeros go across the wire. I think Track It Pacer, I think, is her social media name. She's on TikTok and on LinkedIn and stuff. Actually did some work with an oscilloscope showing that. There's other blog posts that are out there that show, with an oscilloscope, here's a signal going across an Ethernet wire. And I actually was able to decode things looking at the waveform that I see in my scope and so on. It's pretty neat. If you study Ethernet, for example, the encoding methods that are used to put the ones and zeros across the wire, whether it's a physical copper wire or whether it's light going through a fiber optic cable, that's all defined. That's part of the standard how that's done. We don't
Yeah.
care about that typically as network engineers, but that's all part of it. And so when we say layer one, we're talking about the physical. It's a layer one problem. That means you got a cabling problem, probably is
Yep.
what that means. Yeah, probably what that means. All right, so let me take the second one, Holly. Layer two, the data link layer. Frames going between two devices on a shared network. And we talked about frames in an earlier episode. What do you think of when you think of layer two, data link?
I think, frames and switching. And
Yep.
it's what I'm now in hindsight realizing initially when we started this podcast, I'm like, we're starting with frames and packets. Like it's an interesting place to start. And now that I've done this in a different way in my learning, I'm like, wow, I wish I started with frames and packets, because then I got to layer two and layer three and they talk about frames and packets and I had never heard of them before. And now I'm like, oh, I know exactly how this fits together. So hang tight. If the OSI layer you've skipped to this one, it makes sense. There's a thought process here.
And the interesting thing about the data link layer is typically like you said, yep, I'm thinking about frames, I'm thinking about switches, and what you didn't say Ethernet, I don't think, but that is
Yeah.
often what we are thinking of as network engineers is Ethernet. But there are many other kinds of data link layers as well. Ethernet just happens to be one way that we have figured out how to carry data across a local area network, which is again another way that I kind of pigeonhole layer two. It's the local area network. It's the network inside your building. Now you can have multiple layer two networks in your building interconnected with routers and so on, but in your house, let's say, typically you've got one network. You have one access point that covers your house, and that's your layer two broadcast domain. That data link layer is governed by Ethernet and by wireless Wi-Fi signals. Back in the day, because we've admitted I'm old, Holly, that we had other sorts of data link we might need to deal with that was not Ethernet. Frame relay was one that was commonly used in wide area networking. We would build a frame relay network. Do they even teach frame relay anymore? I think that's done, right?
I think it might have been very briefly discussed, but nothing that's actually top of mind. Like I've definitely heard about it before, but it's not actively taught. It's probably in the
No,
same context. Like we did this and now we've moved on.
Yes, exactly. We did this and now we've moved on. Exactly right. I think that's the best way to think about it. There was also token ring was common when I first got started with networking. There was token ring networks were pretty commonly found, typically in IBM environments. Pretty often, you needed to integrate with the mainframe or some other kind of an IBM-based system. You were probably on a token ring network. I worked with a radio station at one point in time that used token ring because the way token ring works, it was helpful to them as radio broadcast engineers to know they could count on data making it around making it onto the ring in a timely fashion, because the token gets passed around from host to host. So you're getting a turn to speak, as opposed to with Ethernet, it being not so deterministic. Okay, let's move on. I just wanted to make the point that there's other things other than Ethernet out there, and historically we got tons of them. And in modern parlance, we've got optical networks and various other sorts of transport that are out there that aren't just Ethernet. Ethernet's the most common one, though, for sure. All right, Holly, layer three, the network layer. What do we got?
So here we have packets going between multiple network devices to deliver data between two nodes. So packets ride inside of frames.
Yes, packets ride inside of frames because you've got a packet. So when we talked about in the packets versus frames episode, we talked about TCP/IP and IP packets happening at layer three, but to get that IP packet from one place to another place, how do we do that? Well, what kind of a local network is it? Oh, it's an Ethernet network. Okay, we're going to put an Ethernet frame around that IP packet. So a network packet the network layer is higher up than that. It's up above that at layer three. And so when when a network engineer is saying layer three, they're typically talking about routers and routing and that. And just to go map back in time, again, history, IPX was another very common layer 3 protocol, inter-network packet exchange, if I remember right. That was big with Novell networks. So when client server networks were becoming a thing and businesses were migrating into client server architectures where they'd have a server in the building and they'd have a PC on a desk, and they needed that PC to be able to talk to that server that was somewhere out on the network. Novell was a company that built the software that would facilitate that connectivity between that client and that server for things like file sharing. We need to share files among ourselves as a company. They're going to live on the Novell server, and you're going to connect to it from your PC, typically running Windows. So the protocol used in the beginning, in the early Novell days, was IPX, Internetwork Packet Exchange. Again, if I'm going from memory, maybe I don't have the acronym quite right, but they didn't use IP at first. They did later on. That came in later in the NetWare 4, and I think they finally standardized on it completely on IP in the NetWare 5 days. And this because the internet was taking over the world at that time, and it was like, oh, geez, everybody's got to get on IP, because many of us as network engineers were supporting multiple network transports, not just IPX and not just AppleTalk or DECnet or whatever else we might have had on the wire, but also this new IP thing. And it's like, well, if we all got to connect to the internet, couldn't we all just consolidate on IP? That'd be nice. And there was a multi-year period of doing exactly that, where we all kind of migrated towards IP and did so. Microsoft went through the same transition with Windows. You could typically run NetBEUI, if I remember right, which is more local of a thing. I don't remember exactly much about NetBEUI, but then they had IPX as well, of course, because you were running NetWare on a network client on Windows at the time, and then IP. And eventually all the other ones went away, and you just were left with IP as your network layer.
Yeah, I can say we started from IP. The rest is very foreign to me.
Because you don't see them anymore. You don't. It's all history. And again, I bring it up just to say, just because IP is the only one you've heard about at layer 3 and Ethernet's the only one you heard about at layer 2 doesn't mean that's all there are or all that there's ever been. There's been so many more and more that exist today. All right, so let's move up to layer 4, Holly. Transport. You got any opinions on what this one's all about?
So, transport, quite literal, making sure that the packets get delivered through acknowledgements or not. They get broken up into segments if they need to be, and then can share a network.
Yes, exactly. So the transport layer, we say acknowledgements or not. Let's give us some examples here. So a protocol that would map to layer 4 would be TCP. Holly, yep. Is that acknowledged or not acknowledged?
That's acknowledged.
It is, and so when we talk about layer 4, often we're talking about TCP, or we're talking about what would be the unacknowledged peer of a TCP?
Yeah, that would be UDP.
UDP, exactly. And but these functions that of did the packet get delivered? In the TCP world, we care a lot. We have a system of acknowledgements that go back and forth so that the sender knows the receiver received the traffic. The sender sends, the receiver receives it, sends an ACK, an acknowledgement back, ACK, an acknowledgement back. Yep, got it. Okay, I'm going to send more, and so on. UDP doesn't actually care. But there's other things that happens at the transport layer that we care about. So one of those being port numbers, Holly. Do you know what port numbers are all about?
I do not actually. I don't think. I mean, yes and no.
You do on some level.
Yes.
Because like HTTP, HTTPS. If I say that, do port numbers pop in your head?
No, they don't actually.
So HTTP port 80. HTTPS port 443.
Yes, of course.
Yeah. Okay, it's okay. I saw the
when you say that, like you say port, and I'm thinking physical ports. I'm thinking
right.
Okay, like GE000. I've never heard of these ports in this context, but when you then say like port 80 and like the numbers, I'm like, oh, of course.
Yeah. So what's happening here is we need a way that you can have multiple conversations going across the IP stack, if you will. So you can, what happens if you were to do on certainly on a Linux box. I forget about Windows, or I think Mac does this too. There's a command called netstat you can type. And if
Yeah.
you do netstat, it'll list at the command line all the ports that the system either has open or is listening on. And it's a way to distinguish conversations that are happening across the IP stack. Well, I'm talking on TCP port 80. I'm talking on TCP 443. I got an SSH session. It's running TCP port 22. Et cetera. And there's lots and lots and lots of these ports that have been defined. So this is happening at the transport layer. We'll be able to differentiate these different conversations with ports. Some ports are dedicated, like a server listening on HTTPS port 443. That's a dedicated thing. A sender trying to, or a client trying to connect to a server on that destination port is going to pick some random port number, and he can choose between all the way up from 0 on up to 65, 535, I believe. Whatever. It's a power of 2 in there somewhere. And there's a few of them that are reserved and so on. Typically, you're going to see a high port, some 5-digit port number that was randomly picked because the system had it available. Okay, this is my connection on my end. I'm going to talk to port 443 on the other end. And then when that connection comes back, the client knows, oh yeah, I know about this connection. I had this port number I opened to have that connection, and it designates what's happening on both sides. You can also do things like segmentation, where you may need to fragment a packet. What happens if a packet's too big to fit through an interface? Because that's a thing. You can have a packet that's too big. Have you heard of MTU, Holly?
Yes. That top of mind.
Oh, of course, in your world, because you deal with VXLAN and tunnels and so on.
So
I suppose
you've got to make sure there's no
unit. That's a thing.
And make sure that it's aligned and there's no MTU mismatch, or the size is correct on both ends.
Well, if it's not, you could run into fragmentation, where you break up that packet into a couple of segments and send it along, and it gets fragmented on the one end and reassembled on the other end. And that's all happens at the transport layer. All right, then. Layer 5 is the session layer. And now we're starting to get into the layers that no one talks about. So
yeah, I was going to say this one, sure, it exists. I, since my day one of training, haven't discussed it again.
Yeah, a session layer is pretty straightforward. It governs how a session starts and ends, such as logging on and off. If there's a protocol that might do that, I'm gonna leave that there rather than dig into it any more deeply, because we're gonna come back to it in a second. Layer 6, the presentation layer, stacks on top of the session layer. The presentation layer controls how data is presented to the application, or sometimes you got to take data, package it up in a particular way, format it a certain way, whatever it might be, for transport across the network. You can think of it as like a translation layer. Okay, I got a bunch of data and I need to do something with it so I can get it across the wire. It could be you're putting headers on it, you're putting metadata around it. It could be you're packaging it in some way for. Think of the presentation layer as presentation to the application, or you're taking it from the application and you're packaging it for send it across the network, and then you're unpackaging it and delivering it back to an application on the other side, maybe to a client on the other side. I'm gonna leave that there as well. But remember, layer 5, the session layer, layer 6, the presentation layer, and now layer 7, Holly, which we do talk about a lot in networking. What is that one? Layer 7.
Now that's the application layer. So high-level protocols such as web, database, and file sharing services. So that's kind of, depending on which side you're on, top or bottom of the stack.
Yeah, I think most people would consider it the top, the highest one, because the application gets, all the rest of it kind of gets like layers of encapsulation as you go down. You could kind of think of it that way. Not exactly, but that would be a way to think about it. So a layer 7, the application layer, is where a lot of the cool stuff happens related to like the web server. You want to talk to the web server. There's HTTP commands. And if you dig into the HTTP protocol, you got commands like head and get and post and there's a bunch of other ones I don't remember off the top of my head, but there's a bunch of them in there. Those are all
Yeah.
defined as layer 7, the application layer. Now, what's interesting to me about the application layer and about applications in general is typically layers 5 and 6, those functions of session and presentation are bundled into the what we think of as a layer 7 application layer. So things like logging on and logging off and how you're going to
Yeah.
package up the data is all defined in what we, again, think typically of as an application layer. It's kind of rare in my experience that you find in networking or in any of these protocols that we deal commonly with in networking are like, this is a unique layer 5 protocol. This is a unique layer 6 protocol. They must exist, but nothing's leaping to my mind at all.
No.
And so, yeah, you either. I got. I mean, I haven't trained on this stuff in quite a while, but I mean, nothing's popping to my mind.
So what's actually funny is I before we recorded this, I got my notes open from when I did this training like a year and a half ago, just to like check in to see what I had written down. And my notes go layer 7, layer 4, 3, 2, 1. So
Okay, I'm not
yeah.
crazy then. I think that
No.
I think that sums it up. Typically, the functions found in the session and presentation layers are defined by the larger application layer that we think of as layer 7, which goes back to my original point that the OSI model, it's like, it's fine. It's got its use cases, but does networking and all the protocols you find map neatly to one of these layers? No, it doesn't work that way. So let's play a game now, Holly. I'm going to take a bunch of common protocols and let's see if we could fit them into the OSI model. I want to see what you think, first of all, about Ethernet. Where does that fit?
Previously discussed, if you're paying attention, that's layer 2.
Aha! But is it just layer 2?
I'm going to go with the yes. I mean, it should be, but I feel like, again, the OSI model is not perfect. So,
But you feel like
you know,
I'm trying to trick you. I'm not trying to trick you, but
I
I
think,
will say Ethernet.
I mean, I think you could extend it, but it's,
well, it's also,
oh, it's a
I would
physical
say it goes
layer.
down to layer 1 as well.
Yeah.
Because the way the encoding is done is defined by the Ethernet standards. That's got to be done somehow.
Yeah.
So you've got physical Ethernet interfaces, right? We've got Ethernet standards that govern things like cabling and how cable pairs are done in say, unshielded twisted pair cable, and the sort of fiber optics and what the standards are for the fiber optics to be able to carry Ethernet across a specific distance. So I would argue that Ethernet is mapped to layers 1 and 2, even though we think of it primarily as layer 2. And functionally, we mostly don't care about the layer 1 stuff. As long as we plug it in and it works, we don't need to know about signaling and that stuff for the most part. If you were doing a building cabling design, distances come into play and the kind of cables you use really do matter. And so on. So I don't want to say you don't care, because there are times you might have to care.
Yeah.
But,
I mean, in high school IT, I learned about cables before I learned about protocols. So Ethernet to me initially, like I thought about cabling. So instinctively it was layer 1 until I got into networking and like, oh, this is actually like a protocol and I'm just using it to refer to copper cables.
All right, so that's Ethernet. The next one, MPLS. What do you think, Holly?
So this is maybe for this reason why the OSI layer is not perfect. This was not included in my training, probably for that reason. And it kind of fits somewhere between layer 2 and layer 3. It's one of those that's not perfect to the model.
Exactly right. It's between layers 2 and 3. Some people jokingly say it's layer 2.5, 2.5. You'll actually see that written out pretty commonly. And we won't spend too much time here at MPLS because we need to devote some episodes around MPLS and MPLS concepts in the future. But for now, suffice to say that MPLS, multi-protocol label switching, is built around the idea of forwarding a packet based on a tag that is put before it. And its roots go back to network equipment makers needed a way to very quickly push traffic across a network. And the silicon was hitting limits trying to do it with IP. They needed something simpler. And an MPLS label or tag was the way that was done. And the way a tag is imposed on a packet happens to sit in between layer 3, the packet header, and whatever the layer 2 header might be. And a device that is MPLS forwarding capable knows how to read that tag and make a forwarding decision based on it. All right, IP, Holly, where's that live?
IP, layer 3.
Layer 3, yep, layer 3. We're not going to stretch that out. And then I'll give you 3 at once here because they all live in the same place. TCP, UDP, and QUIC, QUIC.
So as previously mentioned, TCP, UDP, layer 4, and that encompasses QUIC as well.
Yep, QUIC is also layer 4, and I mentioned QUIC, QUIC. It's coming up as a transport replacement in the internet for TCP. More and more protocols are finding use cases for QUIC instead of TCP. And so if you're new to networking and you're reading up, you'll read a lot about TCP, UDP, and you should be reading up about QUIC as well. It is a transport protocol that should be thought of in the same breath as TCP and UDP, at least here in 2024. SMTP, Holly.
Layer 7.
Layer 7, but I'm going to throw in layers 5 and 6 as well.
Yeah.
Session presentation, I think. Because, if you... So here's a fun trick. You can actually talk to an SMTP server from a telnet session. You can actually telnet. This would be old school in the pre everything's encrypted days, where you could telnet to port 25, which was the plain text, unencrypted, unsecure way to connect to an SMTP server, and actually type in the SMTP commands, which I would argue that's, if you're like the first command you would type to an SMTP server to say, hi, I'm here is hello. I forget exactly what the syntax is, but you say hello. And, okay, I'm a mail server. This is what I can do. Oh, okay. So that's your session establishment right there. That's layer 5 functionality. And then presentation, layer 6 stuff happens within SMTP as well. You've got to format and package the mail message being sent to the server in a particular way, where there's delimiters and there's rules on how you do that. That's presentation stuff. And then at layer 7, you've got everything else that SMTP, Simple Mail Transport Protocol, is doing. So I'm arguing SMTP is layer 5 and 6, as well as the very obvious 7. Yeah. All right, HTTP, Holly, last one.
Well, if you want to, again, I just go with layer 7 because, 5 and 6, whatever. But
yeah, I think
you can just put them all together.
I think layer 5, 6, and 7 is HTTP as well. And I'm not saying that every application, every layer 7 protocol would also include 5 and 6. Just that's a common thing that I've experienced. Okay, Holly. So we've gone through the OSI model. We've talked through the 7 layers. We've kind of highlighted why it's not perfect. But there's also a layer 8, Holly.
It's my favorite layer, personally. Usually one that causes the most problems. And that's the user. So,
that's right. It's the human layer. That's right.
Yeah. It's the human error. It's always causing problems.
And network engineers will commonly talk about layer 8, tongue in cheek, kind of making a joke that it's a human problem, whatever the issue is. And maybe you've heard the acronym PEBCAC, problem exists between keyboard and chair. It's a PEBCAC issue.
I've learned a couple new acronyms that are non-networking, but used by networkers that are quite interesting over my time. I should start making a list.
Yeah, there's a couple of them. PEBCAC was one we used to say, back in the day. There's kind of an obtuse way to say this person's doing it wrong. That's a user issue. And also an ID10T issue. You ever seen that?
Yeah.
ID10T? Yeah. Okay. That's, if you write it down, it looks like the word idiot, right? So we got an ID10T issue.
I learned about RTFM. And if you know about that one. Yeah.
Read the freaking manual. Yes, exactly. Yeah. There's a bunch of those classics that are out there that make their way in IT and all map to layer 8 on some level or another. Okay, if you're out there listening and you want to do some more reading on the OSI model, go to packetpushers.net and you can search for OSI. There's a couple of articles by Russ White. Is the OSI model good for understanding how networks work? Not really. And Russ writes a second part to that, beyond OSI, the four things model of networking. Go read them. They're a very different way to be thinking about modeling beyond the OSI model. And Russ, if you don't know Russ is, I think he's written 13 books on networking. And he's been working in the industry for a very, very long time. He's a good friend of mine. He and I wrote a book together, actually, Computer Networking Problems and Solutions. And Russ and I also did a course together called Understanding Network Transports that you can find on O'Reilly if you want to dig into that a bit more. Certainly modeling comes up quite a bit, and we talk about an early flavor of what Russ's four things model has evolved to. We talk about the RINA model, R-I-N-A, quite a bit. So, okay, we're going to bring this episode to a close. Thank you for listening to N is for Networking. And Holly and I hope that this discussion of the OSI model helped you out. More importantly, don't get too caught up in it. The OSI model, it's a helpful starting point, right? But it is not a definitive reference that all networkers are going to rally around. And again, just to review some of the points Holly and I were making towards the end of the show, you're going to find layer 1 means wires, cables, and interfaces. Layer 2 is probably talking about your local Ethernet, wireless, that kind of thing. And it's a synonym for switching. Layer 3, we're talking about routing. Layer 4 might get mentioned. We were talking about port numbers and stuff, right? And that's usually the context. Someone's talking about port numbers, and someone's got to write an access list or a firewall policy where port numbers are a part of the policy. So layer 4 comes up there. Nobody talks about layer 5. Nobody talks about layer 6. And again, because most often that's baked into the layer 7 application protocol. So don't lose sleep over the OSI model. It's okay. It matters. You're going to hear about it in your training. The layers show up as jargon when network engineers talk, but it's not like all of us that are networkers are walking around thinking in these 7 distinct layers. That's not how that goes. And again, for more information, packetpushers.net. Read those 2 articles by Russ White. And I know that was a long outro, but thank you for sticking with us. I have been Ethan Banks, along with Holly Metlitsky. If you have topics you want us to cover or comments about this episode, send us a message at packetpushers.net/follow-up. And just remember, networking isn't hard. Other people figured it out, so you can too.